So in this video, we will try to understand what is smart grid network. So let's see how we will define the smart grid network. So conventionally, if you see the structure of the power system network, we have the generators which are generating electricity. Then through transmission network, we supply power to the distribution system, and then using the distribution network, the power is given to various loads. So loads can be either residential, commercial, or industrial loads. So this is a typical structure of our current power system network. Then the question arises, what changes we will see when we say the power system network has been transformed into the smart grid network. So what utilities are visualizing that the power system network will be transformed from traditional power system network into a highly flexible, secured and green power system by using integrated communications and advanced control technology. So how we'll add the integrated communication and advanced control technology in the power system network? So let's see what changes we will have when we say the conventional power system network is transformed into the smart grid network. So first change which you will see is the bidirectional power flow, because whether it is industry, commercial or the residential system, those are now being integrated with the solar PV or the small wind farms. So the loads are not only the generators of the electricity but also consumer of the electricity. So that's why being consumer as well as generator of the electricity, consumers are no longer consumers, but they are called as prosumer because they are producing as well as consuming the electricity. So because of that, what is happening? The power is now flowing bidirectionally, because when the load is less at the load center and the generation is more, uh, then this power will be pumped back to the distribution network so that other loads which are not generating the electricity can consume it. Sometimes what happens that overall distribution network cannot consume the power which is being generated by the loads. The distribution network will start pumping the power back to the transmission. So now this is a major challenge in the power system network, because the traditional power system network which you have seen is designed only for unidirectional power flow. Here the change is happening in terms of reversal of the power. So lot of changes we need to do in the power system network, particularly the protection, because the relays now have to see the bidirectional power flow rather than the unidirectional power flow which they used to do earlier. So that is the major change which we will see in the smart grid network. Also, there would be some other integrations happening at various stages. Say the electric vehicle will also be a major load, as well as it can also supply power to the distribution network at some critical point of time. So electric vehicle generally comes with 40 kilowatt hour to 150 kilowatt hour or maybe more in terms of the battery storage. So when the EV is integrated into the distribution network, it can supply the stored power back to the grid when there is a emergency. So it means that the electric vehicle can also be considered as a generator as well as load. at different point of times. Also, we have rooftop solar, we are having wind farms. We are also integrating the microgrids into the distribution network, where the small village will have microgrid setup, including various energy supplying and the consuming devices, and they will only integrate when there is a requirement of energy flow. So those will be self-sustained islands where they can generate and consume electricity on their own, and the extra can be supplied back to the distribution grid. And when there is a deficiency of the power, then they will take power back from the grid. So the major challenge with these kind of setups is that the distribution companies will not be able to figure out when they will consume electricity and when they will supply electricity. So intermittency of the supply and the load will cause challenge in the distribution network. Also, the distribution system are now being integrated with large energy storage systems, which we generally call it as grid connected energy systems. These are used for various functions such as demand response management or frequency regulation. So these are also generators as well as loads for the distribution system. When the battery is being charged, it acts as a load, and when it is supplying power back to the distribution system, it acts as a generator. Similarly, at the transmission level also, we see large size of solar systems and the wind farms are being integrated along with conventional generators. So now what is happening, that generator which we see conventionally as the thermal power plants are now being replaced with other energy sources such as large wind farms and large solar farms. So in this way, the whole ecosystem is being challenged by different devices being integrated into the system. So why there is a challenge in effective utilization of those resources? The major challenge is the intermittency. Solar is sometimes there when the sun is there, solar power is being generated, but suddenly if you have the cloud cover, the solar power reduced to zero. Similarly, in case of wind farm, when wind is blowing, you get the power, but if wind stops, the power output also stops. So those intermittencies which are now being integrated into the distribution system is creating challenge on how to monitor and control the distribution network. So to have the effective monitoring and control of the distribution system as well as the transmission system and the generating resources, what need we need the intelligent ICT network, that is information and communication network. So in this case, what will happen? Every entity which is integrated into the electrical power system has to be communicable. Means they can exchange power as well as they can exchange the information. So until unless you exchange the information at right time, you cannot take informed decisions about the status of the power system, or if there is any critical condition, you cannot take action on that until unless you have the sufficient data available. So that's why the intelligent ICT network is required to transform the conventional power system network into the smart grid. So these will be the backbone of our intelligent uh, power monitoring and control. Now let's see what are the various components which we see broadly in the smart grid network. So first is the consumer devices. We have a lot of intelligent devices now in the houses. Say for example, we have intelligent refrigerators, intelligent washing machines, intelligent dishwashers, and so on. That means these intelligent devices communicate with the network for getting the prices and schedule themselves when the prices are low. So those are the effective tools for having the demand side management at the household level. Say if you are interested to run the washing machine, what you will do, you will just load the washing machine with the clothes and it's just push the button to start. So that is the conventional washing machine and it will immediately start working once you push the button. What is the difference in case of intelligent washing machine? The intelligent washing machine will see in the evening if the prices of electricity are higher, then the washing machine will shift the operation from high prices to low prices. Say if you are uh, pressing the button at 6 p.m. for the washing machine will not immediately operate. It will wait for lower price to come and then it will start its operation say in the night at 10 p.m. or maybe 11 p.m. So the consumer will get lesser bill in case of having the intelligent devices. So the smart grid network will have consumer devices as one of the major components for having the better demand response operations. Now next component is energy providers. Here now not only the conventional thermal power plants but also solar as well as wind farms are now the energy providers. Then we have consumer communication devices such as routers, gateways, sensors, and various communication related devices because all the entities which you see in the smart grid network needs to be communicable. So they will keep on sharing the information for better operations. So you need to have proper consumer communication devices. Then we also need to have conventional distribution and transmission system so that power flows from generating stations to the transmission and the distribution system and then finally to the loads. Now to have the better monitoring and control, we need the network operations. So at the center, you will see there is a network operations center which will coordinate among various entities for better operation of the power system network. So these entities are key entities for the smart grid network. We'll discuss all of these entities in detail when we progress in the course. Now let us try to understand what are various smart grid building blocks. First two building blocks are distribution automation and substation automations. So in last couple of years, we have put more stress on the distribution system automation as well as substation automation. So in case of distribution automation, we have added various sensors in the distribution system, such as fault locator devices, where the devices can sense the fault in the distribution system and the information can be shared immediately to the distribution system operator, which can take action immediately to isolate the fault. Additionally, we also have the substation automation where the substation is now being equipped with intelligent electronic devices where these devices see any abnormal condition or vulnerability in the system which is being governed by the substation and take immediate action to isolate the system and then reconnect automatically when the problem solves. Now, next important component, which is very important for the distribution system, is the advanced metering and communication. At the load end, we install the smart meters and using advanced metering infrastructure and the associated communication network, the information flows to the utility companies, which are now capable to real-time monitor the loads. This will help them to balance the demand supply situation in the distribution area. The next important building block is synchrophasor measurement. Synchrophasor measurement are generally being taken by the phasor measurement units, which are time stamped using GPS clock. So we'll discuss this synchrophasor measurement in detail in the next couple of videos when we'll discuss about the smart grid measurements. And also we'll discuss the wide area monitoring and control, because when we install the phasor measurement devices in the transmission or the distribution system, we have better monitoring and control of wider area. That means that when the synchronized measurements are coming at the control center, the information will be time synchronized, and this will help in better analyzing the condition of the power system network. So these two things we will discuss along with the phasor measurement unit in next few videos. Now the other important building blocks are like distributed intelligence. Distributed intelligence means the devices which we will install in the distribution system will be intelligent enough to process the information locally, and then only the refined information will be shared with the central controller. So in this way, the decision will be very fast, and this will solve the problem of delay which we see in case of our conventional power system network, that we have already seen when we discussed the SCADA data communication. When we have multiple hierarchies and data travel from bottom to top, the inherent delays will be there. So distributed intelligence is also very important to make the system operation very fast. Now, the enterprise application means lot of software applications are required to be added in the power system monitoring and control area, where the applications will be equipped with latest IT architecture, and they will help in easing out the operation of the systems. The other important building block for smart grid is the latest IT evolutions like Internet of Things, data analytics, and cloud computing. So these new innovations in the information technology space are helping to realize the concept of smart grid.